work. When we did it, it wasn't that it was all that hard. You guys all understood it and did very well in the test, but there were a lot of things to remember with it. When we did possible zeros, remember that's when we did the P's, the Q's, and the possible. P is everything that divides the constant. And remember, everything could be a positive or negative. So it'd be plus or minus 1, plus or minus 2. Q is everything that goes into the leading coefficient. So everything that divides 4 is 1, 2, and 4. To find possible, that's P divided by Q. So we have to do every combination. Everything could get a plus or a minus. So 1 over 1 is 1. 1 over 2. 1 over 4. 2 over 1 is 2. I have it. Or, sorry, I don't have it. I need to add that. 2 over 2 is 1. I have that. 2 over 4 is a half. And I have that. So this is my possible zeros. Your final, very similar to last semester. Some questions will be multiple choice and some will be short answer. This would be a short answer question, worth quite a few points because there's a lot involved here. So you have to do that. Then to find our real zeros, first we have to find one that works. So we're taking these numbers, plugging them in until we find something that makes it equal 0. Which one makes it 0? 2. Then we did synthetic division with that. Okay, you have to be able to show your work here. If you just write down the zeros at the end, you don't get the credit. Okay, we did the first one, then we did our synthetic division. 4 comes down, and then it's a series of multiply and add. 4 times 2 is 8. Negative 4 plus 8 is 4. 4 times 2 is 8. Negative 7 plus 8 is 1. 1 times 2 is 2. Negative 2 plus 2 is 0. And we knew that because we already plugged it in and found that it's 0. Remember in our synthetic, this is our remainder, constant, x, and x squared. So we have 4x squared plus 4x plus 1. We could go back to our list of possible zeros, but at this point it's probably easier just to factor. We could slip and slide. So that factors into x plus 2, x plus 2. Divide our 4 back. So the zeros. Zeros are the numbers that make it equal 0. If you set this equal to 0, you get negative 1/2 for both of them. How do we show that it works twice? And what was the other 0? It's x to the third, so we should have 3 zeros. We have 2 of them. What am I missing? 2. Factored form is when we still have the x's. So this would go to 2x plus 1. We have it twice, or you could just put a square. What else am I missing? Right, 2 is a 0, so my factored form has an x minus 2. Right, so make sure you can go through that whole process. The p's, q's, possible zeros, plug them in, find one that works, synthetic division. At the end, the zeros are the numbers, the factored form has the x's multiplied together. All right, problem 2. Factoring. On the top, there's really not much to do. The bottom, we could factor into x plus 3x minus 2. An x-intercept, just like any other time, that's when you hit the x-axis, so y is equal to 0. With these, we talked about if you plug in 0 for your y, you multiply over the bottom, so it's really just when the top is 0. Square root, and we get 0. So I hit the x-axis at 0. Y-intercept, just like any other time, it's where you hit the y-axis. So you let your x equal 0. If you put in 0 for all of your x's, you get 0 divided by negative 6, which is 0. So x and y-axis, we only hit at 0. Does everyone understand intercepts? Asymptotes. Vertical asymptotes are when the denominator is 0. We have it already factored, so that's easy to find. If you set x plus 3 equals 0, you get x to be negative 3. If you set x minus 2 to be 0, you get x equals 2. These are lines, so we give the full equation, and on our graph, we mark these as dashed lines. All right. Horizontal or oblique. You can't have both, it's one or the other. To find that, you divide the highest powers of x. If you take x squared divided by x squared, what do you get? 1. So if it's just a number, that's horizontal, y equals 1. When does oblique happen? Yes, if there's still an x on the top, that's oblique. If there's still an x left on the bottom, that's just y equals 0 for a horizontal one. It means we couldn't divide up. Now we know what happens is we have to hit this point, we have to get closer to our asymptote. So this has to look like an upside down parabola. Make sure it is clear from your graph that you are getting close to it, not touching it. We don't know what the ends do. So this could be up here or it could be down below. I'm going to erase some of this. Get that out of here. So to find out, we had to use test points because remember, we're not going to have a graphing calculator on here. So maybe you put in negative 4. If you put in negative 4, you get 16 over negative 1 times negative 6. So that's 8/3. So negative 4 gives me 8/3. That's up here above my horizontal asymptote. So that piece has to be up here, just curving and getting closer to both asymptotes. Then we need to try a point over here. So maybe we plug in a 3. So that gives me 9 over 6 times 1. So 3/2. So 3 gives me a 3/2. Again, that's up here. So we just use those test points to decide where the final parts go. As many or as few test points as you need. Is that okay? All right, number 3. This is like a quadratic, so we can start by doing slip and slide. X to the 4th would break into x squared. What multiplies to negative 36 and adds to negative 5? We have to divide our 4 back. At this point, you can either go ahead and write it in factored form, or really we're solving it anyway. So we get x squared equals 9/4 or negative 1. We set both to 0. Are you guys with me there? How do you get rid of a square? Anytime we add square root, we have to do plus and minus. So we get x to be positive or negative. Square root of minus 3, square root of 4 is 2. Over here, plus and minus, what's the square root of negative 1? So plus and minus 3/2, plus and minus I. Remember on these logs, anything that has a log in it, we have to make sure we are checking our answers. On number 7, you have 2 logs that are being subtracted. How do you combine those into 1? And then, if there's only a log on one side, how do we get rid of it? Remember, you always start with the base. So it's 7 to the first power equals 3x plus 2 over x minus 2. 7 to the first is just 7. You can multiply over your denominator. So we get 7x minus 14 plus 3x plus 2. When you are checking, you're just making sure that the arguments are positive. So 4 times 3 plus 2 is positive, 4 minus 2 is positive. So it's good. 4 is our answer. All right, there are two ways of doing this problem. It is a quadratic type, but in the past, most of you rewrote it first. X to the negative 2 would put that on the bottom. X negative 1 puts an X on the bottom. Most of you at this point just said, I'm going to multiply by x squared to get rid of all the fractions. So 15 over x squared times x squared is 15. 19 divided by x times x squared gives you 19x. 6 times x squared is 6x squared. 0 times x squared is 0. If we flip this around, now it's just become a slip and slide problem. X squared is 19x plus 90. X minus 9, x minus 10. Divide our 6 back and set those equal to 0. So that gives us a 3 halves and a 5 thirds. Is that okay? Anything else? So you have the rest of the class to work and ask questions. You should have this done tomorrow, and tomorrow we will go over things for the whole class period.